Okay, so just to talk you through this again, what we have is a divisor that is first degree, so we can use synthetic division. We have a dividend that has a leading coefficient of 2. The coefficient of the x squared is -7. The coefficient of the x is 0, and the constant is 5. Those coefficients go in the box, and the 0 of the divisor goes out front. We always bring down the leading coefficient. So we take that 2 and we bring it down. And then we always multiply, then add, multiply, then add, multiply, then add until we get to the end. So we take the 0 out front, multiply by the leading coefficient down under the box, and carry that answer under the next coefficient. We add. -7 plus 6 is -1. Now we multiply the -1 by the 0. And -1 times 3 is -3. We put it under the next coefficient and add. Then we take that -3 that we added to 0 and we multiply by the 0 of 3 and we get -9. And we add. 5 plus -9 is -4. The last number is always our remainder. The number before it is always our coefficient, or our constant, excuse me. The leading term will be x to 1 degree less than the dividend. The dividend was degree 3, so when you divide degree 3 by degree 1, you get degree 2. So you put an x squared with the first coefficient, an x to the first with a second, and obviously the third will be your constant. We end up with 2x squared minus x minus 3 with a remainder of -4, or plus -4 over our divisor of x minus 3. Now, in this particular problem, though, I went ahead and I multiplied both sides of my equal sign by the divisor. So I have the x minus 3 was my divisor, and I'm multiplying it by the quotient, 2x squared minus x minus 3, the answer to my division problem. And when I multiply the -4 over x minus 3 by x minus 3, then the x minus 3's cancel, and I end up with -4. So finally, we have the remainder theorem. If a polynomial is divided by a divisor, x minus c, the remainder is always going to be the value of p of c. So in other words, if you put c into that function, into that polynomial function, the answer you get for the output will always tell you the remainder of your polynomial. So here we have a polynomial p, and it is being divided by the factor x plus 2. Or it's going to be divided by the factor x plus 2. We're going to practice dividing first, and then we're going to show that the remainder we get when we divide, either long division or synthetic, will give us the same answer as when we substitute the 0 of that divisor, -2, into the polynomial function. So here I have 3, 5, -4, 0, 7, and 3 for my coefficients. There's that placeholder because there's no x squared term. So 3, 5, -4, 0, 7, and 3 will go inside my box, and then my 0 of the divisor, -2, will go out in front. I always bring down the leading coefficient, and then it's multiply, then add, all the way to the end. -2 times 3 is -6, and 5 plus -6 is -1. -2 times -1 is +2, and -4 plus 2 is -2. All the way to the end, where that very last answer I get is 5. If we were to go back and put -2 in for each of these x's, and be careful with raising it to an even power, you've got to put your -2 in parentheses before putting the even power, you're going to find that when you do that, when you evaluate p of -2, you're going to get the very same remainder. Okay? That's what this remainder theorem tells us. Okay? So the next and final theorem says that the zeros of a polynomial correspond to the factors. So we know that if c is a zero, then x minus c must be a factor of the polynomial. So we want to show that p of 1 is 0. And if you plug that number in and get a remainder of 0, that means that it is a factor. It divides evenly into that polynomial. So again, our coefficients in this are 1, 0, -7, and 6. If I were doing that synthetically, I have to put in that placeholder. And then I could put the 0 of 1 out in front, and I'd see I get a remainder of 0. But the other way to do it is just to plug 1 in for every x in the dividend and make sure that it comes out equal to 0, and it does. So since 1 is a 0 of this polynomial, then x minus 1 is a factor of the polynomial. Therefore, if I use synthetic division or long division, I decided to show you the example here both ways, I find that my remainder is 0. So x cubed minus 7x plus 6, when divided by the first factor that we found, which was x minus 1, which has a 0 of 1, produces a quotient of x squared plus x minus 6. Now we can factor that quotient. And we have to find two numbers that multiplied together equal -6, but added equal 1. Well, those would be +3 and -2. So our factors are x minus 1, the first one that we found when we substituted 1 in for x, and then x minus 2 times the quantity x plus 3, because that's what our quotient factored down to. So those are the factors of this polynomial. So our zeros are 1, 2, and 3.